Although recent increases in the availability of junk food and decreases in the availability of physical activity have created an obesity-permissive environment, several other factors may contribute. We know, for example, the use of antibiotics is linked to obesity, so our gut flora may play a role. Recently, specific bacterial species were identified. There are these 8 species of bacteria that seem protective against weight gain, and they all are producers of a short-chain fatty acid called butyrate. See, early on, we just thought that there may be some intestinal bacteria that were able to extract additional calories from what we ate, but the relationship between our gut flora and obesity is proven to be more complex. Our gut flora may affect how we metabolize fat, for example, through the hormone FIAF, fasting-induced adipose factor. See, when we're fasting, our body has to stop storing fat and instead start burning it off, and fasting-induced adipose factor is one of the hormones that signals your body to do this, which can be useful for someone who's obese, and maybe one way our gut flora manages our weight. See, some bacteria repress this hormone, thereby increasing fat storage, whereas our fiber-eating bacteria, those that secrete short-chain fatty acids like butyrate when we feed them with fiber, are able to upregulate this hormone in all human cell lines so far tested. Currently, when an individual fails to lose weight, the only other option is surgery. But as the mechanisms of our gut flora's role in weight regulation are elucidated, one can envision transplanting the intestinal contents from a thin person into an obese person. Such so-called fecal transplants may suffer from repulsive aesthetics, though. Turns out there may be easier ways to share. We've known that people who live together share a greater similarity in gut bacteria than those who live apart. Now, this could be because they inadvertently swap bacteria back and forth, or maybe it's just because they eat similar diets, living in the same house. We didn't know until now. Not only do cohabitating family members share bacteria with one another, they also share with their dogs, who are probably eating a different diet than they are. In fact, homes may harbor a distinct microbial fingerprint that can be predicted by their occupants. Just by swabbing the doorknobs, you can tell which family lives in which house. Isn't that wild? And when a family moves into a new home, the microbial community in the new house rapidly shifts towards that of the old house, suggesting rapid colonization by the family's bacteria. Experimental evidence suggests that individuals raised in a household of skinny people may be protected against obesity, no fecal transplant necessary. People may be sharing gut bacteria from kitchen stools instead. And check this out. People living together share more bacteria than those living apart. We already knew that. But add a dog to the mix, and the people's bacteria get even closer. Dogs can act like a bridge to pass bacteria back and forth between people. Curiously, owning cats does not seem to have the same effect, maybe because they're not drinking out of the toilet bowl as much? Exposure to pet bacteria may actually be beneficial. It's intriguing to consider that who we cohabitate with, including companion animals, may alter our physiology by influencing the bacteria that we harbor in and on our various body habitats. Maybe that's why recent studies link early exposure to pets to decreased prevalence of allergies, respiratory conditions, and other immune disorders as kids grow older. I've talked about those studies in which dog exposure early in life may decrease respiratory infections, especially ear infections. Children with dogs were significantly healthier. But we didn't know why. We didn't know the mechanism until, perhaps, now. The first study tying together the protection from respiratory disease through pet exposure to differences in gut bacteria. None of the study infants in homes with pets had suffered from wheezy bronchitis within the first 2 years of life, whereas 15% of the pet-deprived infants had. In comparing stool samples, this correlated with differences in gut bacteria depending on the presence of pets in the home. There was this famous study, 12,000 people, that found that a person's chances of becoming obese increased by 57% if he or she had a friend who became obese, suggesting social ties have a big effect. But given the evidence implicating the role of gut bacteria in obesity, this raises up the possibility that cravings and associated obesity might not just be socially contagious, like you all go out to eat the same fattening food together, but rather truly contagious, like catching a cold.